Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss inequality for one variable, and the content of it is only linear and quadratic inequality. First, we look at some properties of the inequality. If you have A greater than B, then, okay, this one is applicable for greater and equal than B. Then your A will be, if you want to sum left hand side or right hand side, okay. So for example, if you have 3 greater than 2, regardless whether you are plussing a number, let's say 5, left or right, the sign of it will not change. Same thing for if you want to minus 3 minus 5 is greater and equals than 2 minus 5. This sign will not change. Okay, but you need to pay extra attention if you want to multiply. Okay, if you want to multiply or divide certain numbers, if the numbers is less than 0, the sign of that inequality will change. Okay, for example, we take the same example. 3 is greater than 2. If I multiply with negative 1, okay, if you can notice that is the right hand side is negative 2, left hand side is negative 3. So I need to change the sign of become inequality become smaller than. Okay, this one is applicable for divide. So if I have a 3 greater than 2, if I divided by 2, divided by 2, negative, negative. So this one is negative 1.5 is less than negative 1. Okay, so please pay attention when you have the greater and less than. Okay, and then if you have the if I have the positive integer a and b, or any numbers a and b, if you find the reciprocal of it 1 over, so the sign will change. So let us look at the first linear inequalities. We only okay, linear inequalities means that your numerator is the one consists of x, your denominator is not consist of x. If the numerator denominator consists of x, that one is called rational functions, rational inequality. Okay, it's not in your syllabus. Okay, so let us look at this one. 1 minus 3x, and then my denominator is 1 is 2, another one is 4. So if I want to solve this problem, so I just equate my denominator by multiplying this one with 2. Okay, so I have a this is okay, so I will have a 3 times 2 is 6, and then I can multiply my 4 to the other side, will become 20, and then now I just solve normally. So then is 6 minus 18x plus 2 minus x less than 20. So this one and this one actually is negative 19x plus 8 less than 20, or my 19x is less than 12. Okay, now this one negative 19, so I divided by negative 19, and don't forget, change the less than become greater than. Okay, so this is why from the less than change it to become greater than. Okay, if you have the linear inequality, if you are bounded by two different numbers, so you no need to be worried. Just try to move one items per time. Okay, per trip. So now first thing, I move my positive 6 to the left and right side. So we become minus 6. After that, this one will become, okay, so we become negative x less than, this one will become 1, and this one is negative 16. After that, I need to divide by negative 1. So all you want to say is a multiplied by -1 also can. So this one will become -1. The left hand side will become 16, and this one is x, and from the less than change it to become greater than equal. And then after that, normally we write the form of it will become like this, but you can always leave your answer in this way, doesn't matter. Okay, now let us look at another one, is this question. Okay, although the left hand side or the right hand side consists of, okay, if your left hand side and the right hand side consists of x, but because our answer is always need to become x is in between certain thing, okay, and my left hand side and my right hand side is without x, so this one is coming with x. So what we need to do is we separated them into two parts. The first one is 1 plus 3x less than 5x minus 3, and the second part is 5x minus 3 less than equals to x plus 9. Okay, there is an indicator and. Why? Because they are from the same group at the beginning. When we separated them, later on by the end of the day, we need to combine them back. Okay, so now, since I already have this one, okay, so what I do, I shifted my 3x to here, this one to the other side. So I have 1 plus 4 less than 5x minus 3x. So this one is 2x. The left hand side is 5. So my x is greater than 5 over 2. And then this side, we are doing the same thing, shifted here. So I have a 5x minus x less than equals to 9 plus 3. And then I have a 4x less than equals to 12. X is less than equals to 3. And since this one is very convenient, x and x, I can always combine it back to become x less greater than 5 over 2 less than equals to 3. Settled. Okay. Then maybe you say that, can you not doing so by separating things back them? No, because if you want to shift 3x inside here, okay, and then how about the right hand side? Okay, so we just separated them, and then by the end of the day, we combining them back. Okay, now for the quadratic inequalities, okay, ax squared plus bx plus c greater than 0, or you can have less than 0 or less than equals than 0, it doesn't matter as long as our a not equals to 0. Okay, one thing, this one you already learned. Okay, if someone who took at max during your form 4 form 5, this one you already learned. But the thing is, over here we have an extra 2 more method to solve the same similar type of questions, and you are allowed to choose which method you feel the easiest for yourself. But the thing is, you need to know how to use three types of method. Okay, these 3 methods. Okay, so now actually our aim, the first aim is we force our a, okay, we force our a to become a positive number. Why? Actually, if we force our a become a positive number, the methods will become standard, means is we just need to follow the SOP, then we will be no problems in getting the answer. Okay, maybe you say, if you don't want to change it to become positive a, can or cannot? Can. But the thing is, please be careful a little bit for the others method. Okay, okay, now the one you learned during your SPM is called graphical method. Okay, so it's only can use for quadratic. Okay, and what are the other 2 methods that you newly learn here? The first one is called table of sign, and then the second one is called real number sign. Okay, these 3 methods, Okay, we started from the same way, that is obtain the 0 in the right hand side. Okay, so it doesn't matter you have an greater than, greater and equal, less or less and equal, doesn't matter, as long as we keep our 0 on the right hand side. Why cannot be left hand side? Because on the right hand side it looks more natural. Okay, excuse me. After that, one thing is that one, and then we have to ensure our A must be a positive number. Okay, how to get it a positive number means that is we can shift it to the other side, and then our sign will change, or we just multiply by -1. Okay, what is the step 2? We use our calculator to factorize it. Okay, so now, because the, okay, what is the difference between factorizing and the factor or the value, or we sometimes we call it in the graph we call it as a root. Okay, factor means is you write it in a factor form. Okay, after that, how actually your calculator is giving you the root, but it doesn't matter, we can manipulate it later. After that, we use this answer or the this factorize to plot our graph, and then okay, after that, we're going to determine the sign. How to determine the sign? That is the line, okay, the line above the x-axis, actually this is x-axis, we label it with a positive. The one under x-axis, we label it as negative, negative. And if you have the negative ax square, your quadratic will be a set face. So the line above the x-axis actually is at the top, and then the line under the x-axis actually is on the left and right side. Because our method is we started by forcing our A to become a positive. So this one, I will not using this one. I only concentrate on this one, the smiling face. Okay. After I, excuse me, after I have my positive and negative, so I will go to the conclusion. If you're less or less than equal, you will take the negative part. Okay, so what is this one? Later on, you will see the example. You will very clearly knowing that what is this mean. Okay, now, how about the other two method? For the table of sign, first thing I need to determine my critical value. Okay, after that, we put the critical value on the number line. Then we evaluate. After that, the conclusion. For the real number sign, also same. We factor, then we draw number line, and then determine the sign. Okay, now we move on to the example. Then you will know that what all this means. Okay, so let us look at the first question. We have to solve x minus 3, x plus 1 greater than 0. Okay, if this is equals, then you already solved your problem. But this one is greater than 0. So by using graphical method, first thing we plot the graph. Because this one is a positive, okay, it's a positive a square. Okay, how I know that this one is a positive? You take x multiplied by x, actually is x squared. So actually, your a actually is 1, so this one is a positive, so that's why you have a smiling face quadratic. Okay, then how am I know that this is -1 and 3? Okay, so from here we find our roots. X equals to 3 and x equals to -1, so I have a -1 and 3. The one, this is x-axis, the line above, okay, the line above the x-axis, I put the label x. The one under the x-axis, I put it as negative. Now, when the time, how am I going to do my conclusion? So if I want to do my conclusion, I look back through my questions, okay, or I look back the place right after before I find my root. Okay, so this is the time I find my root. So this one is the sign of greater than. So I choose positive. Okay, if this is the sign of greater than, then we choose positive. So the positive is this side and this side. Okay, maybe some of you say that how you want to know excuse me, what is the one I shaded with the line here. Okay, this part, okay, if you have a graph, okay, a line, okay, this is the A, this is the B. The part over here is means my value is greater than B. Okay, maybe some of the question will be having the equal. It depends on this one. Okay, this one without equal, so we don't have the equal. And then this side, on the my left hand side, the value over here is actually is less than my A. Okay, so that's why normally the left hand side and the right hand side, they come with a pair. Either your x is less than A or your x is greater than B. This is an OR. Why is not AND? Because x cannot be less than A and greater than B at the same time. Okay, so that's why it's an OR. Okay, after that, what about the one in between A and B? So that's, as I said, x is in between A and B. So that's why we have three different regions: less than A, in between A and B, greater than B. So the one the leftmost and the rightmost is less than -1. All my x is greater and equals than 3. Okay, so this one don't have the equal sign. Okay, so greater than 3. Or you can choose to write it in a interval form. Okay, negative infinity until -1, union with 3 until infinity. Okay, now the same questions, okay, the same questions, but we use table of sign. Okay, so now from here, this is the factor, and then this is my critical value. Okay, so that's how to find critical value. X minus 3 equals to 0, so x equals to 3. X plus 1 equals to 0, x equals to -1. Okay, and you just simply draw a line, okay, and put 2 strokes here. Then -1 is on my left hand side. My 3 is on my right hand side. Okay, and then I put a divider here. Okay, after that, what I do, I take this factor. Okay, I just label here. It doesn't matter you want to put it down here or up. It doesn't matter. Okay, so after that, how to get this value over here? What you need to do that is, you need to choose 3 different value. Okay, you just choose any value greater than 3. So I choose 5. Why? Because no reason, just because of 5 10 is easier to calculate maybe. Okay, even actually you can use 3.5. If you want, you can choose 3.1, but don't trouble yourself. So I choose 5, or maybe you can choose 10, which is the number easier for you to do the calculation later. And then in between -1 and 3, normally I choose 0 because that is the easiest number. And then after that, I choose any numbers, one number less than -1, I choose -5. Okay, settle. Now, it's the time that we evaluate or test our value. How am I going to test this value? Is I take 5, substitute into this green color. Is 5 minus 3 actually is 2. 2 is a positive number, so that's why I put a plus here. And then I substitute 5 into this blue. 5 plus 1 is 6. 6 is a positive number, so that's why I put a plus here. Okay, then after that I go to 0. 0 substitute into the green one. 0 minus 3 is minus 3, so it's a negative value. So that's why I put negative here. After that, I use 0 substitute into the blue one. 0 plus 1 is 1, so I have a positive number. So I put positive here. After that, on my left hand side, I choose negative 5 just now, and then I substitute into the green. Negative 5 minus 3 is negative 8, so this one is negative, and the last one I substitute negative 5 into here, I get negative 4, so this is negative. Okay, so on the top of the testing we already done, and then how to get the red color sign over here. We use positive multiple positive, we get positive. We use positive multiple negative is a negative, and then negative multiplied negative is positive. So after I have this red color conclusion, then I use the same thing. I look here is greater than, so I choose a positive, so is x less than negative 1, x greater than 3. So the conclusion, regardless you use table of sign, you use the real number line or whatever, your conclusion must be the same. Okay, now we look at the third method. It's called real number sign. The starting is always the same. Then we have the x plus this one, this is our question, and over here you have one statement here. Let the factor, okay, all of your factors greater than 0 or greater or equal than 0, okay. Whether you have an equal or not equal, it depends on the original questions. Okay, now this greater than is not depending here. This is the step that is we let our factor everything greater than 0. This is the step, okay? So that's why I let my factor x minus 3 greater than 0. So I shifted this one to here, will become x greater than 3. This one I shifted to here, x greater than negative 1. After that, same thing, I have my number line, okay? And I just plot this one, x greater than 3. Okay, why there is a white dot here? Actually, you know that is if this is a solid line, solid dot means that it's inclusive 3, but this one is not inclusive 3, so that's why there is a circle here greater than 3, and this one is greater than 1. Okay, now this one is a lot easier to do the sign. Whenever you see there is a line, we put a positive. The place without line, we put negative. And then the same thing, how you get the red sign over here, we multiply. Negative multiplied negative is a positive, positive, negative, positive, positive, positive. And the conclusion, same thing like just now, greater than, choose the positive sign. Okay, so this is how the 3 different methods to solve the same question. Actually, frankly speaking, the easiest is the quadratic, but for the real number sign and then the table of sign, you have a more broad usage if you not only have quadratic, because the graphical method only suitable for quadratic use only. Okay, now we look at, okay, so this is generally I tabled three together. So the conclusion all landed at the same place, and then the starting is always the same. We need to factor. Only the methods is different is this one and over here. Okay, and okay, I forgot to say, okay, so this one is optional, this one is optional, okay, but this one, the 3, 5 is compulsory, so the 5 is compulsory. Okay, now we look at the second example. Okay, now this one is less than equals than 0. By using this one, they already give you the factor. So we try 2x multiplied 3x is 6x squared. Is a positive A, so it's a smiling face. How am I know that these two intercept? So I have 2x minus 2 equals to 0, x equals to 1. And then the second one is 3x plus 4 equals to 0. My x actually is negative 4 over 3. Okay, so I have these two and then smiling. And then I still need to label The one above the x-axis is positive, the one below it is negative, and this one is less than equal than, then we choose the negative sign, and this one count with the equal sign. That means it's negative 4 over 3 and 1. Or you want to write it in the interval square bracket. Okay, now table of sign, same thing. Like just now, how we find our 1 and negative 4 over 3. So this is negative 4 over 3 and 1. And then, so after you get this one, you straight away come here, negative 4 over 3 and 1. Okay, so I need to separate it to 3 different regions. And I label 2x minus 2 at top. Okay, why? Because it's come first. And then 3x plus 4 at the second one. Contrary to this one, doesn't matter. This is how we I show it to you. It's not necessary. This arrangement is not important. A number greater than 5, I choose. Okay, now this time I choose 10. Between negative 4 over 3 and 1 consists of 0. So I choose 0. And then less than 4 over 3, I choose negative 10. Okay, any number you like. Okay, so now I use 10 substitute into 3x plus 4. I know that is a 34. Okay, I know actually you no need to know exact value, but you only need that is knowing that the value you obtain is greater than 0 or less than 0. So this one is a positive. And then I have a 20 minus a number smaller than 20, so positive. And then when I have a 0, this one is 4, is a positive. When I have a 0, this one is a negative. Normally, the one beside it will be negative because this is a linear. And then this one, I substitute negative 10 is negative 30. So definitely this one is minus. Okay, positive, positive, I will get positive. Negative, positive, I will get negative. Negative, negative, I will get positive. And since this is less than equal than, I'm going to choose a negative area, is this one. Okay, so since it's less than equal, choose negative. So this is negative 4 over 3, less than equals this one. Okay, maybe you ask, do you need to write this statement? No. Actually, you can straight away give x negative 4 over 3, 1. But for you later on, for your purpose of the checking purpose, it's easier that is you write this statement so you will know that is you did nothing wrong. Okay. Now, the last one over here, okay, this is the time to show you that this is a compulsory. Although the question is less than equal than, but we don't care. We still let our 2x minus 2 greater and equals than 0. Okay, although this one is less than equal. As I said, we don't care. We just let our factor all greater and equals to 0. And then that means this one actually is x greater than 1. The second one is 3x plus 4 greater and equals to 0. So my x actually is greater and equals to negative 4 over 3. So what I do, I label negative 4 over 3. And then this is 1 greater than, okay, sorry, this one is inclusive. So this one is a solid. So solid going. The one with a line positive without negative. So this one negative. And then our conclusion positive, negative, positive. And since less than, okay, now is the time that we look back to our question. Less than equals than, so that's why we chose negative. Don't look at over here. There is no connection with this one because this one is your assumption. Okay, now if I tabulate 3 of them together, you will see that is the conclusion always will be the same. Only the difference will be the middle part only. Okay, now if you have a question, x squared greater than x plus 2, first thing, we want to force our a to be positive. So we move our x plus 2 to the left hand side. So that's why I have an x squared minus x minus 2. I can use the calculator to give me x equals to 2 and x equals to -1. How to rewrite back into the factor form? If you have x equals to 2, I shifted this one to here, will become x minus 2 equals to 0. So this is your factor. Okay, x equals to -1, shifted here is x plus 1 equals to 0. So this is your factor. Okay, so after I have the factor, okay, as I said, the graphical method is always the easiest. It's come here. This one is a positive quadratic, so it's a smiling face. And then since this is -1, this is 2. So I have the one above my x-axis positive, the one below negative, and I look at my question. This one is greater than, okay, greater and equal than, choose the positive. So I have x greater than equals to 2 and less than -1. Okay, if you want to do by using the table of sign, so the thing is the same. You need the 2 and -1, and choose the value greater than 2 is 5. In between -1 and 2 is 0. Less than -1 is -5. And substitute 5 into here is a positive, 6 is a positive, and so on. And then you coming down here, positive, negative, positive. Okay, now for this real number line, okay, so we starting from the let our factor all greater or equal than 0. So start from here, x minus 2 greater and equals to 0. So your x is greater and equals to 2. And then x greater and equals to -1. So I put over here, okay, sorry, over here I left out the equal. Okay, so after that, the one with the line positive, without line negative, and this is the conclusion. All the conclusion the same. Look back at the one, the last you factor, and then you get your conclusion. Okay, if this is the one you learned during your SPM, okay, for some of you, what if you shifted your x squared to the right hand side? You have -x squared plus x plus 2. If you are using, okay, this one is a warning here. If you are using calculator, your calculator will still giving you x equals to 2, x equals to -1. But if you see x minus 2, x plus 1, if you multiply, you will get x squared. It's not like here -x squared. Why this happened? Because your calculator finding the factor for you is x squared, although you key in negative, x squared minus plus x plus 2 into the calculator means. But the thing is, because this is equals to 0, your calculator will auto assumption is they will shifted everything to become x squared minus x minus 2. So they will give you this answer. So that's why, that is the main reason why we force our quadratic to become a positive one, to avoid you to have the careless mistake in writing this factor in, okay, and this factorizing this factor form. Okay, sorry. Okay, so I repeat, why we force you to write our ax squared in a positive form, to avoid the time you write the factor. If you didn't put the negative here, so that means everything is wrong. Okay, means that if you put your answer as x minus 2, x plus 1 less than equals to 0, that means your conclusion totally is wrong, because it will be have a revert answer. Okay, so now if you want to use this one, carry on. So it's a set face, because this one is a minus, so it's a set face. And then above the x-axis is a positive, below the x-axis is the negative. And since this question is less than equal, we choose the negative. So this is your answer. And if you see that the answer are the same. So that's why. But the thing is, this one can cause more careless mistake because of this negative. Okay. But if you are familiar with this method, you can go ahead. Okay, now how about we have an x squared minus 3x greater than 0? Okay, this question is no different with others. The only thing is because of this factor. Okay, because this factor, okay, if you key into your calculator will give you x equals to 0, x equals to 3. So sometimes, okay, certain time you will get confused, okay, how to write the factor x equals to 0. And then because x equals to 3, you will say x minus 3. But how about x equals to 0? If you, at sometimes during, if you are panicked, you will just put x minus 0, no harm. Actually, no harm. Actually, but the thing is, after you write here, maybe you will notice x minus 0 actually is at x. Actually, that's what is correct. It's only x. If your factor is x only, will give you the answer is x equals to 0. Okay, so no difference in doing. So the left hand side is 0, the right hand side is 3, and then above is positive and negative, and I want to do conclusion is greater than, so I choose positive, and this is my answer. Okay, so now let us look at question 5. Okay, any different? Yes, maybe this one. What is the difference? Maybe this one have more terms, and we want to preserve the positive sign over here, so that's why we send our 5x and 8 to the other side, and we have this one, as I said, key into the calculator and they give you this answer, and then this is the conclusion. Okay, now let us look at one question. X squared greater than this one. So how am I to answer this one? I send this one here. Reason I want to preserve this one as a positive. So I have an x squared minus 2x minus 24 equals to 0. So this one actually is minus 6x plus 4 equals to 0. So I have, okay, as I said, if the question didn't mention what method, I also will use the quadratic method. Okay, sorry, this one I forgotten. This one is negative 4. This one is 6. And I need to label positive. I need to label negative. Okay, sorry, this one is not equal. Okay, greater than. And I also will say, since greater than, choose positive. To alert myself that is I look at the, I have a proper indicator here, greater than, choose positive, so that means is here, x greater than 6, or my x is less than negative 4. Maybe some of you say, can you interchange? You write like this? Of course, can. Or if you don't like this way to write, you can always write at the top. And this one is optional because I just put there. If you want, just write the one behind is sufficient enough. Okay, so now this one, wow, is more things, but when you see that is when your x squared is being x squared by 2%, okay, is in the middle by 2%, and that the left and right consists of x. What comes in your mind? Separated them into two different parts. The one first, 6 plus 4x less than equals to 2x plus 3x. And then the second one is 2x squared plus 3x less than 3 minus 2x. After that, I shifted everything to the right hand side because I want to preserve my positive. So greater than 0, 2x squared minus x, okay, 4x shift here is become minus 4x, so it's minus x, minus 6, okay. If you not, excuse me, not familiar with this, we can always change it to this side. Okay, maybe sometime you will just think how to make sure this sign is correct. You just look at the shape. This is your 0, the sharp part is pointing at your 0, so that means over here we just putting our 0, and the sharp part is pointing at our 0. So that means this sign is already correct. And then after that, then we need to factor these questions. Okay, so as I said, I don't have a calculator. So 2 and this is 3, I think so. So, and then this one is minus. So I have a 2x plus 3 and x minus 2 greater and equals to 0. So as usual, smiling face. And then this one is 2. This one is negative 3 over 2. Okay. And don't forget label positive, positive, negative. And since, okay, I have no space, I write down here. Since greater and equals, choose positive. So my conclusion I put here, because I don't have a space. So x less than equals to negative 3 over 2 or x greater than equals to 2. Okay. After that, my part left hand side settled. How about my right hand side? Since this is a positive, I shifted everything here. 2x squared. And then this one shifted here become plus 5x minus 3 less than 0. And then since I need to get it, 2 and 1, and then this is negative 3. Okay, sorry, positive 3, and then this is 1. So I have the 2x plus 1 and my x plus 3 less than 0. X equals to x. Okay, so I have smiling face, negative 3. This one is, okay, sorry, this one is negative. Okay, sorry, this one is negative. So this one is negative 3. This one is 1 over 2. And then positive, positive, negative. And since it's less than, I take the negative part. So it's x in between 1 over 2 and negative 3. Okay, because of this question, this is the answer. Okay, this is the answer from set 1. This is the answer from set 2. This is my set 2. Okay, my left hand side and right hand side. Now, because they are originally from the same parents, okay, so this is an and, I need to combine these two answers together. Okay, so how am I to combine? Okay, I draw my number line. Okay, I look at how many numbers I have. Negative 3 over 2. Okay, so I have negative 3 over 2. I have 2. I have negative 3. I have 1 over 2. Okay, 3, negative 3 over 2. 2, negative 3 and 1 over 2. So this is 4 numbers and I need to arrange from the smallest to the largest. So negative 3, negative 3 over 2, half and 2. Okay, after that I start doing the number line, labeling that less than equals to 3 over 2. That is an equal, so it's a solid coming down. 2 solid going up. In between negative 3 and half is an empty. Okay, I draw here empty half. Okay, now why this thing? Okay, you have to remember the answer from the set 1, they are one pair of answer. So that's why they are in the same line. Okay, this one, they are not from the same set. That's why it on the above. Okay, or you want to draw it at the below, doesn't matter. Because our connector is an and, so what we need to do, we do, okay, this is only the place they are intercepting. Okay, both of them sharing the same part, two lines having the same thing. So my answer is negative 3. This one is solid, but the top here is a whole. That's why I have an less than x equals then negative 3 over 2. Okay, or you want to write it in this form also can. Okay, so we have a few questions for you to try on. This one I will discuss this in another video. Thank you.